Welcome to Metal Welding Lecture Series by Professor Joyjeet Ghose. This is the 7th lecture of a series of lectures. This lecture will be on submerged arc welding, SAW, plasma arc welding, PAW, and stud arc welding processes. He will be discussing about the submerged arc welding process, fluxes used, power source in SAW, electrode size. He will also discuss the SAW welding basic equipments. SAW advantages, limitations and applications are also discussed. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to lecture 7 of a series of lecture on metal welding process. In this lecture we'll be discussing 2-3 arc welding processes. First one will be submerged arc welding process, second one will be plasma arc welding process, and another very unique arc welding process, that is stud arc welding process. So these 3 arc welding processes we'll be discussing in today's lecture. So don't miss out and watch the full video. So in gas metal arc welding have found tremendous application. However, when we want to weld very thick material, we found it's not very suitable. So there was always a lookout for techniques of welding where we can weld efficiently thick plates. And submerged arc welding is a process which is capable of welding thick plates, and the deposition efficiency of submerged arc welding is also very high. So and the deposition rate is also high, efficiency is also high, so it gives a very good clean weld. So what is this process? This is also an arc welding process which produces a coalescence of metals to be joined by hitting them with an arc, and here the arc is produced between a bare metal electrode and or electrodes. There may be more than one electrodes, and there may be more than one arc, so therefore it's called arc or arcs. So we will be discussing with one electrode and one arc only. So the arc is produced between the bare electrode and the workpiece. So the bare electrode gets consumed by the arc heat of the arc, just like MIG welding or gas metal arc welding, which I have discussed in lecture number 5. So here we do not use fresher. If filler material we also normally do not apply required, because we are already using a consumable electrode, but sometimes may be given separately if you want to add additional material, but normally we do not use additional filler material in this case. But one of the major limitations of this welding is that it is limited to flat and horizontal position because of the nature of the welding process. Now why it is called submerged arc welding, we'll be discussing in the next slide obviously, because in details next slide, but primarily you can say the arc is submerged by a layer of fluxes or a blanket of fluxes. So this flux are normally granular flux that depends, selection of the flux depends on the wire electrode and the base metal. So the flux is continuously deposited in front of the electrode, and there is a flux feeder which feeds the flux, and the electrode moves behind the flux feeder, and there is another there may be another vacuum system which may collect the unused fluxes. So it is somewhat like this. You can see here, this is the granular flux hopper which deposits the flux in front of it, and this flux completely engulfs the arc. Now, so there is no chance of any oxidation, so the weld quality is very good. So there is no chance of oxidation, spatter is nullified, and the arc is highly constricted, so the heat is intense, and we can obtain deep penetration. So therefore this process is capable of of welding thick metal plates. So if you want to weld thick metal plates, this will be alternatives for such cases, and the amperage varies from 300 to around 1000 ampere. Maybe sometimes it may go to around 2000 ampere depending on the requirement, and the electrode varies from 0.8, 1.62, 2.5, 3.2, like that. It may go up to 8 or more. Normally it is around 4.5 to 6. maximum. So typically includes thick plate welding of shipbuilding, fabrication of pressure vessels, pipes, etc., etc. How do we start the arc? The arc may be starting by this touch start method, or we can use a steel wool to initiate the arc. That is also possible. And whatever the slag that is formed has to be removed, and you can see whatever the flux that are unused can be recovered and can be reused. So what are the fluxes that are used? The oxides, various oxides are used. We will be discussing later, and the current setting varies from 300 to around 1000 depending on the diameter of the electrode and the thickness of the plate. The wear feeding is around 5 meter per minute. It is a standard depending on the wear size and the ampere setting again. So the system looks like this. There is a hopper which deposits the flux in front of it, and the flux engulfs the bare electrode. The heat of the arc produced by this electrode is intense, and it is totally covered by the flux, so there is no spatter and there is no chances of oxidation. An unused one is connected by a vacuum system. So what sort of power source do we use? The power source normally that we use is constant current for if the supply is AC. If it is DC, we prefer that the electrode is positive. Now why do we prefer electrode positive in DC welding in this type of submerged arc welding process is that it gives it gives us deep penetration. It gives us deep penetration. Electrode negative, it will be deposition rate will be increased, but penetration will be less. So for electrode positive, the penetration rate will be high. So we prefer that. These are the fluxes. Fluxes can be of various types like manganese oxide, silicon oxide, manganese silicate, calcium silicate, aluminum rutile, fluoride basic, and alumina basic. So these are various types. It can be mixed of more than one also. So you have to select judiciously the flux based on your electrode wear material and the base metal. So we call it active flux when you can add manganese and silicon to the weld. So such fluxes are called active fluxes. So we use titanium, aluminum, calcium, zirconium, magnesium oxides basically, and calcium fluoride, etc. Now fluxes are of 4 types basically. Bonded fluxes. In bonded fluxes we use a low melting point bonding material like sodium silicate to bond the fluxes together, and normally this type of fluxes contain deoxidizers which prevent any kind of weld porosity and can be effective in this type of fluxes over rust and mill scales. Whereas fused fluxes are basically heated. The flux mixture is heated to a high temperature and they form a fused mass which is broken and to required size and then can be used. So however, it has certain limitations like it do not have the deoxidizers at high temperature. You cannot add the deoxidizers, so that is an issue with fused fluxes. And then we have agglomerate flux, which is the same as that of bonded flux. However, we use a liquid binder here, ceramic binder. And mechanically mixed fluxes are also available, which is basically a mixture of one or more bonded type flux or agglomerated flux to achieve certain specific properties. So power sources, as I have said, submerged arc welding operate with DC or AC. When you are using DC, the electrode is connected to the positive terminal. So that gives us more penetration. So we can use with DC electrode negative to obtain more deposition rate. But here our intention is to obtain more penetration to weld thick metal plates. So therefore, when using DC, we normally use electrode positive. And of course, AC when you are using, we use constant power source. And for DC, we use constant voltage power source. And for AC, we use constant current power source. So 2 types of power source can be used for this here. So when you are using DC, we require constant voltage power source because we want the arc to be self-regulating. So in such cases, we will be requiring the constant voltage power source. The AC such requirement is not there, so we can use constant current power source. So this is a basic idea about this wear stick out. For different diameter of the wear, this should be the stick out. Stick out means how much the electrode wear will stick out from the gun. Okay, so for different amperage setting, the deposition rate is given here. It's an indicative type. For different wear size, you can see the wear size. Applications basically for thick plate welding of cast iron, stainless steel, copper, nickel, alloys, etc., etc. Advantages: deep penetration is obtained, welding is fast, quality of the weld is excellent, and there is no spatter. Deposition efficiency is also very high. However, limited is large volume of slag has to be removed, and it can be automatic, it can be semi-automatic. Welding is restricted to horizontal position only, and the process is not recommended for high carbon steel, tool steel, aluminium, magnesium, lead, or zinc. The reasons: because for this type of material we do not have the suitable fluxes. So this is another figure of this same, some figures of the same process. You can see here it will follow this, and the hopper deposits the fluxes. This is the power source which is separate. Okay. So then we have plasma arc welding process. In plasma arc welding process also it's an excellent technique for welding. It gives a narrow weld, clean weld, but however plasma arc welding is not that much popular compared to plasma arc cutting or plasma arc machining. PAM is much more popular. However, let us discuss the welding process in brief. So there can be two types: transferred arc type and non-transferred arc type. In transferred arc type, the electrode is negative and the workpiece is positive. The arc is established between the electrode and the workpiece, whereas in this case the arc is established between the gun itself and the electrode, and then the heat is transferred to the workpiece. So here two type gases are used. One is the plasma gas, other is the seeding gas. So the plasma gas is basically an inert gas is used for making the plasma, which can be argon and mixture of argon and helium, and similarly argon and helium mixture can be used for seeding. So from here the seeding gas comes out, and from here the plasma gas comes, and the electron discharge will make it plasma, and which will be transferred to the arc is then transferred to the workpiece, which is sufficient to melt and form a coalescence of the two metal pieces which you are joining. The electrode is a non-consumable electrode. If you require additional material to be added, which has to be supplied separately, but mostly we are interested in thin plate joining, so additional material is okay. So plasma arc welding is invented and patented in 1953 by a person called Robert M. Gage of Lind Union Carbide Laboratory, New York. After 10 years of this patent, it became commercially available from 1960s, or 64 rather to be precise. So it gives much more control and accuracy compared to other arc welding processes, and electrode life is also high. It can be manual or automatic. Nowadays we have automatic plasma arc welding processes. The temperature of the plasma is extremely high, around 11,000 degrees centigrade. At that temperature it can melt and even vaporize the known material, so we have to control it properly. The seedling gas can be a mixture of argon and hydrogen mixture, and the plasma gas can also be this mixture. So the power levels used can be of different ranges, depending on different plasma. So difficult to weld materials can be bronze, cast iron, lead, etc. can be welded by this process. So one of the advantages is that it is a good arc stability, better penetration compared to other arc welding processes. High travel speeds, excellent weld quality can be produced by plasma arc welding. So there can be three variations of it: microplasma, when the current rating is very less, 0.1 to 15 ampere, medium current around 15 to 200 ampere, and at high currents 15 to 200 ampere, the process characteristics plasma arc are similar to TIG welding, but the plasma is constricted and the arc is stiffer compared to that of TIG welding. And although the plasma flow rate can be increased to improve the weld penetration rate, there is a risk of air and shielding gas entrapment through excessive turbulence in the gas shield. At higher current, plasma can be used as a keyhole plasma, almost like an electrode beam welding process, where during the welding the hole progressively cuts through the metal within the metal pool flowing behind to form a weld bit under surface tension forces. So the keyhole moves forward and the weld is completed behind. So the process can be used for weld thicker material like stainless steel in a single pass. Okay, so it can be used for precision, for small part welding, for high production welding. Okay, next is stud arc welding. So basically it's a stud, as the name suggests, it's a welding of stud, very simple method of welding studs to any plates. So there is a gun in which the stud is mounted, and there is a ferrule which protects the arc. In the next figure you will see. So this is the gun holding the ferrule, the stud, and this is the ferrule which covers the arcing. So again, when you switch on, the arcing will start. The heat of the arc will melt this surface, and it will be formed a joint, and then we remove, and the stud is welded to the plate. So this is a very simple technique of welding a stud to metal plates. So it should be positioned perfectly perpendicular. The trigger should be actuated and released, and the gun should not be moved. At the completion of the weld time, the gun should be held in position momentarily, allow solidification of the molten metal. Then remove the gun and ferrule and inspect the weld. So the welding stud normally range from around 3.2 mm so up to around 31 mm. So it's a very simple way of welding stud to the plate. Ferrule, what is that? It concentrates the arc, protects the weld pool, confines the metal, prevents the charring and disruption, reduces possibility of open arc flux. Okay, so we are finished with today's this lecture. Next lecture we'll be discussing some other welding processes apart from the arc welding processes. We are finished with arc welding processes with this, and hope you had liked this lecture, and thank you for watching this.